With our environment set up and our first custom hook built, new possibilities open up. Hi everyone, I'm Sebastian Perez and welcome back to the series where you will learn how to build efficient hooks using Uniswap Hooks contract library. If you missed our previous video, no worries, you can find the link below in the description. In this video, we'll be building on top of the base async swap hook, which is perfect for scenarios where the external logic is deferred. For example, waiting for off-chain computations or oracle responses. The base async swap hook skips the pool manager's default logic for swaps and simplifies this process by ensuring that the net balances remain at zero, leveraging the custom accounting feature of Uniswap before. Before jumping into the code, let's break down one of the key libraries that makes it all work, the currency settler. The currency settler library is a useful component that provides helper functions to facilitate the transfer of value into and out of the pool manager. This library offers two primary functions that align with two critical concepts, settle and take. The settle function allows you to make payments to the pool manager. You can either transfer the specified token amount directly, or, if applicable, you can burn the ERC6909 tokens as payment. The take function allows you to receive payments from the pool manager. Similarly, you can choose to receive the specified currency directly or opt for newly mint ERC6909 tokens. By using the currency settler library, the base async swap hook can maintain the net token balances at zero by minting ERC6909 equivalents and effectively bypassing the swap logic. The base async swap contract inherits from the base hook, sets the necessary permissions to override the before swap function, and implements the custom logic within it. As we can see, this contract is designed to work with exact input swaps. This means that the swap involves a fixed amount of one currency being exchanged for the maximum possible amount of the other currency. In simple terms, you specify the amount of a token and receive the maximum amount of the other token in return. Here's where the custom logic comes in. The hook takes the specified amount of the input currency and mints the equivalent amount of ERC6909 tokens. So you are spending the input currency, but keeping the net balance at zero because the mint ERC6909 tokens offset the spent amount. Now, let's walk through an example to see how this could work in practice. Imagine that you are implementing a hook for an exact input swap, but you want to delay the swap for the half of the specified amount. For example, if the user sends 100 tokens to a swap, 50 of that tokens will be spent and mint as ERC6909, and the other 50 tokens will proceed through the regular swap. For this scenario, you can use the base async swap code and override it. First, you have to override the constructor. It's very easy, it's always the same. I will override the before swap function with the same code as it is in the base async swap, but modifying the specified amount as the half of the one received in the params. Using this value, the hook mints the ERC6909 tokens equivalent to the half of the input amount. And it's important to notice that the delta returned by the function will also reflect this split. So instead of returning the entire amount that would bypass the swap entirely, the hook returns half of the amount, enabling the regular swap proceed as expected for the other half. We explored the base async swap hook and walked through an example of how to split a specified input amount between minting ERC6909 tokens and executing a regular swap. Do you have any innovative ideas for how this hook could be used? Let me know in the comments. If you are enjoying this series, don't forget to like the video, subscribe to the channel, turn on the notifications so you won't miss the next video where we will dive into the hooks designed for defining custom fees. Thanks for watching and I'll see you in the next video.